Hi everyone, thanks for joining. We'll be talking on building a data platform to process over 50 billion in card transactions. I'm Sandeep, I'm engineering lead data platforms. I'm from Dojo. If you don't know about us, we are the fastest growing fintech in Europe by net revenue. We power face-to-face payments for around 15% of card transaction in the UK every day. We are mainly focused on experience economy of bars, pubs, restaurants, even your local corner shop or farmers market. We also have a consumer-facing app that allows you to join the queue for a high street restaurants for up to around 2 miles radius. We have an amazing line of payments products. We have tap to pay, pocket pay. We also provide the small business funding, and we are also building many products to change how the payment industry works. We are going international soon. Hopefully you will see us in every corner of Europe first and then in the world. What makes us different, I guess, and also makes all of this possible is the fact that we are highly data driven and value the insights in our decision making. When you go to a shop and when you tap your card, and within a blink of a second, your transaction happens there and you get the goods, and the customer, the merchant, basically for us it's a customer, but the merchant who is selling you the goods or selling you the services get the money. All of this happens within a blink of a second, as we just talked about. When you tap a card, the first thing happens is the card machine takes the details from the card and securely sends these to the authorization gateway. At Dojo, we use point-to-point encryption between the card machine and our authorization gateway with hardware security modules in multiple facilities with direct pairing to multiple cloud providers. It's highly secure and highly scalable. We can't let our authorization gateway down because that's the main point from where we take the transactions. The authorization gateway then contacts the card network such as Visa, MasterCard, Amex, and then forwards this request to the issuing bank for approval. This will be someone like your bank in UK, Barclays Card, Monzo, Tesco, who will then freeze the funds on the customer's account. In support, it's very important to know that the money, the actual money, has not exchanged yet, and it is just a promise for a payment that can be reversed as well. The card network then sends this approval back to the authorization gateway, which is then displayed to the customer as approved or declined, and this is how your card transaction actually works. And this whole process generates a lot of data from a payment point of view. Because we are a payment company, so we have a couple of regulatory challenges where we have to, we own the end-to-end payments experience. So we operate under, e-money license from the FCA, which is a financial conduct authority. With this comes strict regulatory requirements, most notably the fact that we have to ensure the whole time that customer funds are safeguarded in case the business becomes irrelevant or insolvent. Then you have PCI DSS level 1 compliance, which is around safeguarding or not safeguarding, storing of full card numbers. So owning the whole payment stacks with full card numbers, we also have to comply with PCI DSS level 1, and we also are independently audited every year to ensure that we actually follow all the rules and guidelines provided by PCI. Then we have other complexities around schemas. So we process, I guess, more than 1,000 plus data contracts or schemas. And this talk, sorry, I completely forgot to mention, this talk will be around file processing. So I'm going to just talk about how we built the processing of these files coming from different sources and all these schemes, Visa, MasterCard, and all the payment boxes we have. So these the 1000 schemas, as I said, and then you have multiple file sizes and multiple formats. So it's just not like you have, standard file size. Okay, we're gonna have a size range from 5 MB to 10 MB. It doesn't work like that. We have like files which are 2 KB, 10 KB, 50 KB, I don't know, and then it goes up to like gigabytes. And then we also get like zipped files as well. Then you have a scalability. You can have unpredictable demand. Sometimes we have, I don't know, 500,000 of files coming right now because of SLAs between multiple sources. They overlap and all of the file comes at the same time. And then all of those files sometimes are business critical. So we have to process all of them at the same time. So for example, if you see this is a snapshot of internal reconciliation process performed by our payments analytical engineering team, just to ensure that a merchant's net settlement tallies with the transaction that have been actually authorized on the tills in their shops. And as you can see, like there's like CSVs, XLS, XML, that many files required to get just that done. And also another bit, like all the files coming in doesn't just have XLS or XML. They have all the file formats possible. They have we have JSON files. We even have Avro files now. We have Parquet files as well. We have fixed width files. We have then this proprietary formats created by this scheme companies like Visa, MasterCard. For that, you have to write very, very heavy custom parsers to actually make sense out of those files and put them into your transactional kind of data warehouse. And the goal which we came up, or the goal which we thought would be good for us to actually take all of these file formats, process them into a final single format, which can be then later utilized by processes downstreams to stream that into warehouse, or stream that into Kafka, or stream that into Snowflake, or stream that into anywhere else wherever we want. And we chose Avro because of most of the powers around schema evolution, and mainly that, I guess. But there are multiple different formats which you can choose, but we chose Avro at that point. And it's not just payments. There are a lot of other business areas in the company which are important. They produce a lot of events, data, and also generate a lot of files data, and that can be coming from APIs, or that can be coming from external tools, or that can be generated by their own microservices. So to support the processing of files with all the schema evolution and with the scale and with all these challenges in mind, it was very important for us to design a data platform which is scalable and self-serve. And now, before deep diving into the modern data infra processing and how we have done it, I would like to take us back into the history of data processing. There were three generations of data processing. First generation was the generation of enterprise data warehouse solutions. Big giants like Oracle, IBM, Microsoft were building those big warehouse which only few people know how to use. Then came the era of big data ecosystem, the era of Hadoop, the era of Pig, Hive. Spark came into the picture. We built those monolith, big, centralized, beefy Hadoop big data platforms, which was again only utilized or monitored or operated by few people, and huge bottleneck and huge number of skill shortage to actually make the huge to make the use of it, I would say. Then we talk about current generation, mostly centralized data platforms, mix of batch and real-time processing based on tools like Kafka. Apache Beam also gives you the flavor of the mix real-time and batch processing. Then PubSub, then Red Panda, then all sort of cloud managed services like AWS, GCP, other cloud providers like Confluent, Avon. They are giving their own managed services on top. While this centralized model can work for organization, right, that have a simpler domain with a smaller number of diverse consumption cases, it failed for us because we have rich domains, a large number of sources, a large number of consumers, and most of the companies who are going through such a growth, they also have this problem, and this centralized data platform really doesn't work, and there are other challenges with it. The challenge that the centralized data platform is mainly owned by a centralized data team, which is focused on building, maintaining data processing pipelines, then building data contracts, working hand in hand with stakeholders. But at the end of the day, there's no clear ownership on that. Then issues, support for all the domains without actually having the domain knowledge. Then you have silos, then specialized data team, which will keep on adding features if they get some time away from the support issues or everyday change requests. Then another issue is data quality, accountability, democratization of data. It's very difficult to enhance or put measures for data quality if there is no clear ownership on the data. The fact that data team manages data access, it makes it a bottleneck when it comes to access request. Then scalability, adding new data sources, increased data volumes, data contract changes, etc., can be delayed due to a huge data team backlog, because they are the one who are actually managing and maintaining the data pipelines, and the byproduct of this also is not such a great relationship between data team and the other teams, and also a lot of blame game when this goes wrong. And over the last decade or so, we have successfully applied the domain driven design into our engineering or operational side. But as a whole data community, as a whole engineering community, we completely forgot to put that into the data side. Now, what should we do in this kind of scenario, right? How should we go on, and what is the right way of building that file processing platform which we built at Dojo, or any kind of data platform which you might want to build it, or anybody wants to build it. Now imagine this, right? What if the centralized data team will only focus on creating a generic data infrastructure, building self-serve data platforms by abstracting away all the technical complexities and enabling other teams to easily process their own data. Apart from that, they will also provide a global governance model and policies to have better access management, better naming conventions, better CIs, better security policies. And at the same time, data ownership moves from centralized team to the domains. I have said domains many times in this chat so far, but by domains, I mean teams that are working on a certain business area. For example, payment, marketing, customer, etc., etc. Now, this whole approach brings a set of benefits. Finally, the data is owned by people who understand it better. Company-wise, you reach a better scalability by distributing data processing across the domains. Domains are now independent, and they are able to add new data sources, create new data pipelines, fix the issues by themselves. Domains can put better data quality and reliability measures than the centralized data team because they understand it better. Domains have the flexibility of using only what they need from the generic data infrastructure and self-serve data platform features, which reduces the complexity, blast radius if things goes bad, and things always goes bad. And having said that, the centralized data team should make sure that there is a good monitoring, alerting in place to monitor all the flavors or features of data platform across the domains. Now, this approach will also enforce well-documented data contracts, data APIs, which will allow data to flow seamlessly between one system and the another system. It can be internal and external as well. And having domains owning their data infrastructure brings more visibility on resource allocation and utilization, which could lead into cost efficiency. Now, this whole concept is, my friend, is data mesh. Now, data mesh is I know I'm talking a lot of theory right now, but I will come back how we build that dojo. But this is very important. So, data mesh is like domain ownership. Is one of the best, or no, sorry, not one of the best. It's one of the important pillar. It's your data. You own it. You manage it, and if there is a problem with it, you fix it. Data as a product. Data is not a byproduct. Treat your data as a product, whether it's a file, whether it's an event, whether it's a warehouse, or whether it's a beefy table, all of that, treat it as a product. Federated computational governance. Each domain can set their own policies or rules over data. For example, payment domain sets encryption standards on payment data, or marketing domain sets retention on the customer data to 28 days to adhere to GDPR standards. Then the final and my favorite bit is self-serve data platform. This is the key in all of this. If you successfully build this, which means self-serve data platform, you've got 80% things right. This will enable teams to own and manage their data and data processing. But the big question is how you're going to build it. It looks easy now, but when you have so many choices and so many people pulling you in conferences that their data platform is the best, they have the one-stop solution, it can be quite overwhelming. But I guess based on your use case, you will do certain POCs. You would try to look at probably open source solutions available before buying already, I don't know, committing to thousands and thousands of pounds or thousands and thousands of dollars to some managed providers claiming that they can solve all your problems. When we were building this file processing platform, we were quite sure that the platform as a service or self-serve platform offering was the only way to move forward. Now, on a high level, 4 main features in our platform provides this end-to-end solution for file processing, which we just talked about before, that we have 20 plus different types of files coming in, and then we have around 500k files every day coming in, which we have to process, varies in different size, and then they come in certain hours, and we have to scale the system accordingly as well. Now, 4 components. First component is source connectors, which is ingesting data from external providers in a consistent way. So we did build those connectors to bring the data. Then you have PCI processing platform, which actually makes sure that the clear credit card information is stored, masked, and processed successfully and very, very securely, and then being sent to non-PCI platform. And the non-PCI platform, which takes all the non-PCI data and also the data coming from all these other domains and everywhere, and perform schema evaluation. I always struggle with this word, and data validation, and generate outputs into that final format which we agreed before, Avro, and basically chunked Avro, because the file size is being different, the source file size. So we make sure that the final Avro files are chunked into like somewhere around roughly to the same size. So we don't end up having like one Avro file, which is 2 gig, and one Avro file, which is like few KBs. Sorry. Then target connectors. Streaming the data generated Avro files, let's say from this lake house kind of, or distributed data lakes, into the data warehouse, or into any other streaming system, or into any other external kind of like warehouse, if Snowflake, or loading that into MLOps platform and things like that. Now let's deep dive into all of these components. Connectors, source connectors. We have a number of different data sources. We have, storage buckets, we have external APIs, we have webhooks, we have Gmail attachments. Trust me, we still have processes where we have to get the data from attachments. Then we have external SFTP servers. So mainly we use rclone to move most of the data which is coming in files. It's an amazing open source utility which comes very handy when you want to move files between 2 storage systems. You can move from S3 to GCS, or SFTP to any kind of storage bucket, and it works like a charm. But you have to be very, you have to spend some time on the configuration part of it. Then you have webhooks. So we have, if the data was not in files, for example, in case of webhooks, we batch those events into files to keep things consistent. And we did have some strict SLAs, but we did not have SLAs to process this information in real time. So in those cases where we don't have adhere, kind of like SLAs, okay, we need to process this information straight away. We also use like webhook kind of like connectors, which batch those events and send them into the files. I guess we are moving that completely into our streaming side now. I guess that was a historic decision which we took. Then we have serverless functions, which allows the data to be received automatically by email, including email body. I just talked about the email attachments up there. We have one provider that does not attach a file, but provides a system configuration message in the body of the email. So we had to write a parser for that as well. I know we always have use cases like that. And then we use these connectors to land the data in the PCI and non-PCI platforms, like depending on the sensitivity of the data. So if we know that these files are encrypted and they are supposed to be processed by PCI to get the credit card information masked, they directly go to the PCI platform. And if they are not, they then bypass that process and directly go to the non-PCI platform. Before jumping into the PCI platform, just a few lines on what is PCI compliance. So all the listeners would understand how much complexity is, or how much things you have to consider while building a PCI data platform kind of environment. Adhering to PCI standard is one of our prime concerns, given we own the end-to-end payment stack. And these standards are a set of security requirements established by the PCI SSE to ensure that credit card information is processed successfully within any organization. Some of the key points from this compliance are, at a high level, they are like all the credit card data has to be transmitted through secure encrypted channels. And then clear card numbers can not be stored anywhere unless they are anonymized or encrypted. Then you have the data the platform which deals with the PCI data has to be audited for any security concerns every year. So when we have PCI, so this is our PCI management process within the PCI platform. We have those files coming in. We don't know the size of the files. They are zipped. They are encrypted. So we have to decrypt the source file in memory using confidential computing nodes. Then we encrypt with our own key and archive the files for future purposes and for safeguarding. Then if it's a zip file, we unzip on the disk. If the file contains pans, we open the file, we mask the pans, then send the masked version of the file to the non-PCI platform, because it's masked, it doesn't fall into the PCI category. And this is how the overall processing looks like. So as you can see, the files start arriving. Sorry, it's a bit smaller for me. Yeah. So the file starts arriving into the PCI storage bucket. And this is all running in GKE in Kubernetes. Our clone is running as a cron job in Kubernetes. For object storage, we are using GCP. GCP is GCS, and for queues, we are using PubSub at the moment. So just so you know that we are completely GCP based. But most of our workloads and most of our processing power runs on GKE. So it's a good mixture of being cloud native as well as cloud agnostic at the same time. So these connectors are running, they're pulling the file from SFTP or storage or S3, and then these files arrives into object storage. The moment the file arrives in object storage, a file event has been created. That, okay, the file is created, and that goes into a PubSub queue. And then based on the number of messages in the queue, the HPA will scale the workload. We will talk about scaling in detail in the later part of the presentation. We typically have around 300 pods running at peak hours across 40 nodes to process around 300 or 200k files within like 30 minutes. Pods will then fetch the file information from these events in the pub/sub topic, process the files, mask the content if required. We have very strict SLAs, and scaling of the platform to meet those SLAs is a critical part of our architecture. We are using horizontal pod scaling and cluster autoscaling together to scale the platform. A bit more about autoscaling now. Autoscaling is a crucial part of our platform. We have to process these files as soon as they arrive, so we can perform the settlement and billing operations, and also pay our merchants and do the reconciliation of the money, which is very crucial to our business. Also, on the other hand, we also wanted to make sure that our infrastructure is cost effective and we are not running workloads when they are not needed, to be aligned with a bit more like a FinOps culture. There are a few challenges we faced when we implemented horizontal pod scaling. Setting up resources, like on the pods, that was a bit difficult to decide what should be the starting request and what should be the limit. I know there has been a lot of talks in Kubernetes that we don't need to put limits and stuff like that, but in our case, we had to do it because we are scaling so many pods, and pods can consume like a lot of memory and resources. So we tried a lot of different options. When we were trying this in production, we started hating PagerDuty, but eventually everything worked out for us. It's now scaling quite nicely, and there are two types of scaling available, right? High level, two types. We have horizontal autoscaling, which updates a workload with the aim of scaling the workload to match the demand. It actually means that the response to increase the load is deploy more pods. And if the load decreases, scale back down the deployment by removing the scaled pods. Then you have vertical autoscaling, means assigning more resources, for example, memory or CPU, to the pods that are already running in the deployment. You can trigger, there are multiple ways to trigger this autoscaling. You can trigger based on resource usage. For example, when a pod's given memory or CPU exceeds a threshold, you can add more pods if you want to. Then with metrics within Kubernetes, any metrics reported by Kubernetes object with the cluster, such as, I don't know, input, output, rate, or things like that. Then also like metrics coming from external sources like pub/sub. For example, you can create an external metrics based on the size of the queue, configure the horizontal pod scaler to automatically increase the number of pods when the queue size reaches a given threshold, and to reduce the number of pods when the queue size shrinks. This is exactly what we did. And this is exactly what we did and used to scale our platform. We are talking about, so far we talked about HPA and adding more number of pods to scale the deployment. But we also need to remember that Kubernetes cluster also need to increase its capacity. Now, how do we do it? How do we fit all these scaling pods into Kubernetes? For that, we need to add more nodes, and we use Kubernetes cluster autoscaler. Kubernetes cluster autoscaler is a tool that automatically adjusts the size of Kubernetes cluster by scaling up or down by adding or removing nodes when one of the following condition is true. There are pods in the pending state in the cluster due to insufficient resources, and there are nodes in the cluster that have been underutilized for an extended period of time, and their pods can be placed on other existing nodes. One very important thing to remember is that if your pods have requested too few resources when it first started, and after some point, your pod wants more CPU or more memory, but your node is in which your pod is actually running is experiencing resource shortages. in this case, cluster autoscaler won't do anything for you. We actually did not read the documentation properly, and we believe the other way around, and we lost good couple of days trying to figure it out why the processing is very slow. You'll have to go back and review the resources for the pods all the time. And now we know the HPA and CA works together to scale the platform, and here is and it works hand in hand, and our files processing can like becomes very scalable all of a sudden, because we adopted Kubernetes and all these flavors of scalability with it. And this is how it actually looks like, right? Now, if you can see, I'm going to take you back again to the processing. You have object storage, all the files are landing, and then the queue is having those events of file creation, right? And the queue is becoming big and big and big. Now, how do we scale it? We said unact messages that means this is the pub/sub terminology, but that means not processed events divided by 4 is equal to number of pods or number of workers required. Now, but we still have a maximum limit as well. For example, if I have 500k files still needs to be processed, I cannot be running, I don't know, 125k pods. So we can still say, okay, maximum 300 or maximum 400 pods can be running at a certain point in time on this particular cluster. And that actually works because the file processing is very fast. So within few seconds, it processes one file, or within a second or so. This is how the non-PCI platform looks like. And sometimes this is the platform where all the validation, all the schema contracts, all the monitoring events, and everything kind of is encapsulated into this group of microservices or collection of tools or infrastructure, as you can say. So all the collector, it works exactly the same as PCI, just a bit more that it has some extra flavors of schema registry and file stores and things like that. So all the connectors send files into the source bucket, which is non-PCI bucket. Then file creation events generate that file creation event into the topic. Then HPA comes into the picture. It scales the deployment of these translate pods. We call them translate because they're doing the translation based on the config provided. And then the CA, cluster autoscaler, kicks in to scale the cluster. And then the translate pods actually parse and translate every single file, every single source file into chunked ever files. Now, translate process completely works based on what's inside the schema of the file. And this is where it becomes more like a self-serve data platform. So every single pipeline belongs to a single domain. Payments have its own pipeline here. Marketing have its own pipeline here. And every single schema registry, if you see there, it's like one schema registry at the end of the day. And there is a UI on top of it from where users can log in, go, and change the schema. They can say, okay, now this file contains an extra column, and I want to process this extra column, but I don't want to go to the data team and raise a request and ask them to process this. I would like to do it by myself. And this is how it happens. So they go to this web interface, and there's schema versions, schema names, source, blah, blah, blah. A lot of information there. We are actually trying to make it a bit more nicer now. We are actually taking away all the configuration out. Now we have Argo CD workloads and things like that. So we're taking that all out, and we're just leaving the schema bit there. But the gist here is like the users can actually, or the domain owners or those teams can actually manage their own pipelines by themselves. We provide the data catalog by using Data Hub. They can discover everything what they need to do. That is also an ongoing project at the moment, but it's very interesting. Maybe someday we'll talk about this more. Then we provide monitoring on top of it. The schema registry also have a component where you can say you know what? I want to know when my file arrives and when my file lands into the BigQuery or my data warehouse. And if that doesn't happen by 9 o'clock in the morning, I'm gonna get alerted because my processes are gonna fail and I need to notify downstream stakeholders, any other reason. So that's how the schema registry plays a very key role. And at the end of the day, it's a data contract between the source and the processing and the target. When we process files from PCI to non-PCI environment with the help of schema registry, the file moves from many different stages throughout the whole processing journey. And the state management of the file becomes very important because you want the file processing to be fault tolerant. You want to handle errors when the error happens. You also want to support kind of live monitoring. You also want to prevent duplicate processing because queues can have duplicate events. And you want to make sure that once the file is processed, it's processed. Now let's see how the flow works. So object file is created. It goes into the file event subscription topic, for example. So then it's kind of in a to-do state. And after that, the HPA is listening to that topic. And then it say, okay, let's scale everything. And all the pods starts consuming from this topic. And they consume from this topic. They goes first to the store, file store, or you can call it a data store or state store, to check whether the file is already being processed by some other pod or not. If that's the case, then they skip it. If not, then they put that status into in progress and then they start processing it. And if everything is succeeded, they said, okay, translate is completed, or translate was started before, translate completed without any error. Everybody's happy. And if that doesn't happen, if there's an error, then they say, okay, there was an error. And for some transient errors, we can actually resend the file to be processed again. So they put the status of the file to do again so that some other pod can pick it up. This is also very useful for monitoring. So all these events are being sent into metric store, and then we have a file monitoring service which actually talk to the schema registry. And based on the config provided in those schemas or feeds, what we call, it actually aggregate this information and start generating metrics report or alerts or send more aggregated information to Grafana. And for infrastructure observability, so most, as I said before, everything what we do and everything what we run mostly is on Kubernetes. So we are running Prometheus integrations at the moment, getting all the important metrics such as resource usage, pods health, nodes health, pub/sub-queue metrics, etc. Whatever to literally to Grafana, and then we have live dashboards running which actually reflects the status of the platform, and the users can actually go and see their own feeds, their own pipelines, and see if anything is down or not, and they also get alerted, we also get alerted, because the centralized team own the infrastructure, so they actually come as a second line support to fix if the issues are happening there. I'm not going to touch much into the analytics platform, but analytics platform is made basically to analyze all the raw data which is coming into BigQuery, and then run some DBT models, and then create those drive tables and then the insights out of it. This is also, everything is based on Kubernetes, and then this can be also, this is really, this whole deployment of analytics platform is owned by every single domain. So payments have its own, marketing have its own, customer has its own, everybody have their own kind of analytics platform. This is my kind of like a showcase end-to-end file monitoring, and this is actually the Slack message look like. If you see that stage 1, stage 2, stage 3, stage 4, stage 5, and see the stage 4 is failing, and the user can just click on it, which file is failing, and then from there we have playbooks, and then we have ways to identify the errors and ways to fix them as well. this is how the overall ecosystem of data platform looks like. I just talked about today the PCI platform and data file processing platform and only touched the analytics platform, but we have done a lot of work in streaming side. We have done a lot of work in discovery, observability, quality, governance, developer experience, and we are still doing a lot more. And we still have to go a long way to completely embrace this self-serve data platform or data mesh. And if anybody is interesting, please join. Go to this dojo.career page. Not just data team, we are hiring across I guess all the functions, and of course thank you for your time, and if you want to DM me directly or connect me on LinkedIn, this is my profile. Thank you so much. Have a good day.